In this class, I want to discuss about the double integral. And the double integral of are two types. So, double integral we can evaluate under two conditions. So, what are those conditions? Those two conditions are: first one is double integral defined over bounded domain, and the second time is double integral defined over bounded region. So depending upon these two types of region and domain, we can able to evaluate the double integral. So let me start with the double integral which is defined over a bounded region, bounded domain. So let me start with double integral over a rectangle. This bounded domain you can say a rectangle also. Why it is rectangle I will tell you. Over rectangle. So let f of x comma y be a bounded function. Bounded function we can abbreviate it as BDD. Bounded function defined over a rectangle defined in a rectangle R. That rectangle is denoted by AB semicolon CD. Remember in this expression the first two quantities represent the limits of x and second two quantities represent the limits of y. So f of xy be a bounded function defined in a rectangle R, then the double integral over the rectangle R is given as double integration over R f of xy dx dy. And here if I want to evaluate individually, we can say integration a to b and then integration c to d. Since c and d are limit of y, so I will write here f of xy dy, and a and b are limit of x, so I can write here dx. Remember, in the double integral which we are evaluating first will be inner integral, and the integral which we will evaluate at the end is called outer integral. So here inner integral is integration over c to d f of xy dy, and outer integral is with respect to x. So first we evaluate the inner integral. We will put the limit of y, and whatever thing we will get, that one we can integrate with respect to x, and then we will put the limit of x. So here I want to say one thing. You don't think that this is the only possible way to integrate this one. If somebody want, they can integrate first with respect to x, and then we can integrate it with respect to y. Then also you will find that both the things are same. So here first in the first expression, inner integral is with respect to y, outer integral is with respect to x. But in the second expression, inner integral is with respect to x, but outer integral is with respect to y. So you can evaluate the double integral defined over a rectangle in any one of the way. But one thing you have to take care, you are taking the limits of the variable x and y in the proper manner. So whatever order you are taking, in the same limit you have to take, and then you evaluate it, both the things will give you same answer. For example, so here I said that it is over a rectangle. So suppose this is my xy plane, and suppose this is my rectangle. So here you see that this is my x-axis and this is my y-axis. X is from here to here. So I can have here A, I can have here B. So this limit is the limit of x, and y is from here to here. So I can say this is my lower limit C, this is my upper limit T. So this is my region over which I am evaluating the double integral. So here everything A, B, C, D all are constant, then only this is possible. And so constant means it will form a rectangle, and that's why we say this is the double integral over the rectangle. Now I will take simple example here. Example, let us take example here. Example is evaluate double integration x square plus 2y x square plus 2y dx dy dx dy, where r is nothing but 0 comma 1 semicolon 0 comma 2. So this is your question. Now we have to evaluate, you can say over r. So we have to evaluate this double integral. We have to evaluate this double integral over the rectangle 0 comma 1 to 0 comma 2. That means it is the rectangle of this time. If this is my x, so I can have like this. This is my thing. So here, sorry, this reverse thing I did. Here I will go, the value of x is 0, so y is 0, so we will start from here. So I can have like this. This is my rectangle. So this is my y-axis, this is my x-axis. So here x is from 0 to x is from 1, and y is from 0 to y is equal to 1, 2, y equal to 2. So this is my rectangle. Over this rectangle I want to evaluate this double integral. So in the rectangle R, you see that, as I told you, first pairs are the limits of x, second pair are the limits of y. So this double integral we can write here as double integration over R. F of xy is nothing but x square plus 2y dx dy is nothing but, let me keep x as outer integral, so I will put 0 to 1 limit of x, and y as inner integral, so I will put the limit of y x square plus 2y, and since I have put inner integral with respect to y, so I put the limit of y as 0 to 2 and x with x limit is outside, so I will put the outer integral as x. Now if I evaluate this, what I will get is 0 to 1. I will not make any change here. So let me integrate the inner part first. Inner part x with respect to y, x is constant. So integration of x square with respect to y will be x square y. So I can put x square y. Integration of 2y with respect to y is y square by 2 and 2 is there. So I can cancel it 2 into y square by 2, and then I will put the limit of y from 0 to 2, and then whatever answer I will get, I will integrate with respect to x. Now here we see that the upper limit of y is 2 and lower limit of y is 0. So let me first put the upper limit and lower limit. Upper limit, wherever y is there, I will put 2. So upper limit means it will be nothing but 2 x square. So I will have 2 into x square. Here y, these two will get cancelled. So y square means 2 square plus 4. So this is my upper limit minus lower limit. I will put y is 0. 0 into x square is 0. And here y square 0, 0 square is 0. So this will be the thing, and I will integrate it with respect to x. After that, I will once again simplify it. Integration 0 to 1, and this is 0. Remaining thing is 2x square plus 4, and I will integrate it with respect to x. Now, what is the integration of 2x square with respect to x? So I will have 2 is constant, it will be as it is. Integration of x square is x cube by 3 plus integration of 4 is 4x, and the limits are 0 to 1. So if I put the limit x equal to 1, what I will get? I will get the upper limit is 2 by 3 plus 4. And if I put x equal to 0, I will get 0. So finally what I will get here, 3 into 4, 12 plus 2, 14. So 14 by 3. This is the value of this double integral over the rectangle 0 comma 1, 0 comma 2. Now suppose here I put y as inner integral, x as outer integral, but suppose some of you may want to put x as inner integral, y as outer integral. That means integration over r x square plus 2y dx dy. So that means I will put y outside and I will put x inside, and x square plus 2y. First I will integrate it with respect to x, then after that I will integrate it with respect to y. Then also you will get the same answer. The answer will be 14 by 3. This is the way we can evaluate the double integral. Now I will take another example here. Example, evaluate. The question will be like this: evaluate double integration over r dx dy divided by x plus y plus 1 whole square, where r is nothing but 0 comma 1, 0 comma 1 semicolon 0 comma 1. That means the limit of x is from 0 to 1, limit of x is from 0 to 1, limit of y limits of y are from 0 to 1. So my rectangle is like this. This is my 0 comma 0, and here I can have, this is my x axis, this is my y axis, and so this is my y equal to 1, so I can have the square like this. This is the square. This point will be nothing but 1 comma 1. So my aim is to evaluate this double integral over the rectangle, this, okay, over the rectangle this. Now how can we evaluate? So before going to this, I will recall you integration dx by x square. How can we evaluate it? What is the integration of this one? We write here integration x to the power minus 2 dx, and integration will be x to the power minus 1 minus 2 plus 1 divided by minus 2 plus 1, and so we can get minus 1 by x. This is the integration of this. Now in the similar way, here we are having x plus y plus 1 whole square. So when we will integrate with respect to any one of the variable x or y, the other variable will be treated as constant. Now how can we integrate it? So now let us find the double integral. Let us find the double integral. So let me write this one as double integration over r dx dy divided by x plus y plus 1 whole square. So I want to put x is outside. Here there is no problem. You can put any one of them outside and any one of them inside, because all the limits are same, x plus y plus 1 whole square. So x I am putting inside and y I am putting outside. So this integral is inner integral, and with respect to y is the outer integral. So I will apply this formula. I will apply this formula. In place of x I am having x plus y plus 1 whole square. So what is the integration of that one? That will be nothing but integration 0 to 1, and integration of that one is nothing but minus 1 by x plus y plus 1. As you see that here integration of x square is minus 1 by x, but in place of x square I am having x plus y plus 1 whole square. So the integration will be 1 by x plus y plus 1. Okay, and then we can put the limit, we can put the limit 0 to 1. Whatever answer we will get, we will evaluate it later with respect to y. So now remember, these limits 0 to 1 are the limits for x. So wherever x are there, x is there, I will put the upper limit as 1 and lower limit as 0. So if I do that, what I am going to get is, here I can have minus, I will take it out, and then upper limit I will put, upper limit is 1, so x is 1, already 1 is there, so I will get y plus 2. Now if I put to lower limit of x, that is 0. So here it is 0, so remaining thing will be y minus 1 by y plus 1. So this is, we will integrate again with respect to y. With respect to y. Now here again I want to recall the thing. We know that integration of dy with respect to y is nothing but log y. But here you see that in place of y you are having y plus 2. And so what will be the integration of y plus 2? The integration of y plus 2 will be nothing but minus is already there before. It will be log of y plus 2. Okay. And minus log of y plus 1. Then you put the upper limit and lower limit here and simplify it. So upper limit is 1. What will happen if I put y equal to 1? So minus of log 1 plus 2 is log 3, minus if I put 1 log 2. Okay, and then if I put 0, I put 0, so here it will be upper limit, then I will put the lower limit. So if I put y equal to 0, I will get log 2. And if I put here y equal to 0, I will get minus log 1. Upper limit minus lower limit. So minus what I will have here is log of 3, and here minus log 2 minus log 2. So minus 2 log 2, and log 1 is 0. And so I can say minus of log 3 minus log 4. And you can write here, finally you can write here log 4 minus log 3. And so what will be the thing? Log of 4 by 3. And this will be your answer. This will be your answer. Similarly, here you can integrate with respect to y first, and then integrate with respect to x at the end, and you put the limits, you will get the same answer. So this is the procedure we follow to evaluate the double integral. Now I will take another example here. Integrate, evaluate, evaluate double integration over r x sine x plus y dx dy, where r is nothing but 0 comma pi semicolon 0 comma pi by 2. So limit of x is from 0 to pi, limit of y is from 0 to pi by 2. So here you have to think little bit cleverly. What is the thing you have to think here is, you see, x into sine x, integration, to integrate x into sine x, we need by part method. Simply you x sine x dx. To integrate it, we need by parts method. Okay, so if I take first integration with respect to x, so at the first step itself I have to use the by parts method, which will make me difficult. It is not like that you will not get, but it will be somehow time consuming and complicated. So in order to avoid the complication, you have to cleverly select the inner and outer integral. Okay, so here what I want to say is, this integral I will, or I will prefer to keep y as inner integral and x as outer integral. Why so means that already I said. So here suppose I will put x limit is outside 0 to pi, and then inner integral. So with respect to y, x will be constant, so we can take it out, and the remaining thing will be 0 to pi by 2 sine x plus y. And I will integrate with respect to y first, then I will, after that I will integrate with respect to x. So when I will consider the y inner integral as with respect to y, then this x will be not integrated, we can keep it outside, and I have to integrate only sine. Okay, and which is easy, we know the integration of sine. Instead of using the by parts, we can integrate sine x easily. Okay, integration of sine x is nothing but minus cos x, minus cos x. Okay, so we can use that one easily. So in place of x, I will have x plus y, but with respect to x, y is treated as constant. So either it is x plus y or x minus y, the integration will be with respect to x, so it will be unchanged. So that is the reason when you are getting such type of thing, you should take the inner and outer integral very carefully. So otherwise you will face difficulty. It is not like that you will not get, but thing is that you have to be clever to do the thing easily. So now what I am doing is I am putting x outside. Now I will integrate sine x plus y. Sine x plus y with respect to y will be cos x plus y. And what are the limits? The limits are 0 to pi by 2. And whatever answer I will get, that I will integrate with respect to x. Similarly, now here what I can do, minus is outside, so I can take minus 0 to pi. I have x, and then I will put upper limit as well as lower limit. Upper limit is pi by 2. So I will have, this is the value of y, I will have pi by 2 plus x, and then minus cos of 0 plus x. And this thing I will integrate with respect to x. This thing we will integrate with respect to x. Now, what is the value of this one? So let me write cos x plus pi by 2 or pi by 2 plus x is nothing but sine x minus sine x, and so we can put here this is equal to this is equal to integration 0 minus is there, integration 0 to pi x. This one will be minus sine x, and this one will be minus cos x dx. Since minus is everywhere present, so I will multiply with this minus, and what we will get here, integration 0 to pi x into sin x plus cos x dx. Okay, now you can use the by parts method. So here first function will be x, and the second function will be sin x plus cos x. Now according to the by parts formula, first function into integration of second function. So this we can do here. Here we can write here first function into integration of second function sin x plus cos x with respect to x minus integration of integration of integration of sorry derivative of first function. Derivative of first function means d by dx of x into whatever integration we will get from here. Here I will take as it is. So sin x plus cos x dx. Okay, whatever integration I will get here, that I will put here, and I will integrate the whole thing with respect to x. I will integrate the whole thing with respect to x. And so what I will get here, x into integration of sine is minus cos x, and integration of cos is sin x plus x sin x, and the limits are 0 to pi 0 to pi minus derivative of x is 1, so remaining thing is 0 to pi, and here integration of sine is minus cos x, integration of cos is plus sin x, and then I can integrate it. So what will I get here if I put the limit in the first term? So first term will give you upper limit minus pi cos pi plus pi into sin pi. This is the upper limit minus lower limit minus 0 cos 0 plus 0 into sin 0. So this is the evaluation of the first integral. This is the evaluation of the first integral. And the second integral, I will have minus integration of cos is sine. So I will have minus sine x. Since minus is already there. And integration of sine is minus cos x. And the limit is 0 to pi. The limit is 0 to pi. Finally, you simplify cos pi equal to cos pi equal to, so here I can have sin pi is 0, cos pi is minus 1. So I can have like this, I can have like this minus pi into minus 1 plus 0. So this one 0 and this one is 0, 0 into something 0. So here this one, so I will take pi common, I will take pi common, I will take pi common, so minus pi I will take common. So now cos 0. So what I will have here, minus pi, cos pi is minus 1, okay, and then sin pi is 0, okay, and then next one will be this, if I put minus plus, and so sin pi plus cos pi upper limit minus lower limit sin 0 plus cos 0. So finally, if you simplify it, you will get pi, and cos pi is minus 1, and here sin 0 is 0, and this cos 0 is 1, so minus 1. So finally, you will get it pi minus 2. So this is the procedure we follow to evaluate the double integral defined over a rectangle.